Hello, my name is Ulrik Stridsman. Error recovery is a topic that is easy to forget. I hope this presentation will help and give some guidance. This is an old known code that I found suitable for this topic. As long as NSO is processing transactions and pushing configuration to devices, we don't need to know about it. But when things break, it is important that we get to know about it and we get good detailed information what has happened to be able to make a good decision how to solve it. The way we want our orchestration solution to work is that we put in our intent, we commit it, and so starts to process it, and eventually it will succeed. But sometimes things doesn't go as expected, and it fails. Before it fails, NSO sometimes makes a number of retries to see if it was just a temporary error and it might succeed with a new attempt. One of NSO's success stories is its atomic transactions. They make life easy for anyone who wants to be in control. Either it works, everything's rolled back and you're back where you started. At completion, you know if it was okay or not, combined with a good error message. Depending on the type of error, you either wait or fixes the problem and then makes another attempt. This is really good, but the downside is the lower throughput. A transaction will never be as fast as its slowest device. What do we do when atomic transactions are not good enough? Maybe we need higher throughput. Okay, then we enable commit queues. Maybe we need to allocate an IP address. We might need to allocate a VLAN ID as part of the service. No problem. We start to use nano services. Our system may have grown large, and the limits in memory or CPU makes us think in terms of a distributed system. That works too. Let's move to an LSA architecture. But all of those have one common denominator. We lose the clear observability we get when using atomic transactions. When digging into this topic, I found there are two distinct types of errors. First, we have the transient errors. This is a type that is considered temporary and it might work if you wait some time and then try again. Connection-related problems is maybe the most well-known type of transient errors. Power outage is one reason and is more common in some countries than others. An upcoming reason here is that devices might be turned off during night to save power. But there's also device-related problems. One that I know is if the candidate database in the netconf device is locked by another transactions. Then there are also some NSO internal errors resulting from execution of services or commit queues. But I will not go into any details of those in this talk. Finally, we have permanent errors. This is a type that have the characteristic there is no need to retry. It will fail until you have fixed the underlying problem. Here I mainly find device-related problems. Out-of-band chain is probably the most common cause, and the device will become out of sync. It can also be that the device is improperly configured or has bad configuration. NSO have a few settings that control the behavior when it comes to error handling. Read timeout and write timeout are considered as permanent errors, and the transaction is aborted. It has the same behavior both atomic transactions and when using commit queues. The green values are the default values. These settings control how NSO behaves when it comes to connecting to a device. This setting may depend on which NED you're using. Connections are considered as transient errors. Commit retries is a setting I haven't put much attention to until this last year. This one is a little bit different, and I will get back to that. One scenario when it's used that I know is when the candidate database of a netconf device is locked. Finally, we come to the retry settings for the commit queues. As the name suggests, this will only be used when using commit queues. When and how are the settings used? How many attempts will be made? This is a question I've had for a long time. So I have done some research. When there are connection errors and when you use atomic transactions, the number of retries will be connect retries plus 1. It's obvious, very easy to calculate. If you use commit queues, then you multiply that with the commit queue retries plus 1. It might be a lot of retries, but it's okay. Getting back to this specific scenario where the candidate database is locked. Here is where commit queue retries plus 1 will be used. And if you use commit queues, you multiply it with the commit queue retries plus 1. When digging further into error cause, I found a few netconf related RPC errors in use and resource denied. And from NSO perspective, we only handle this as a transient error when using commit queues. It feels a little bit odd, but that's how it works today. There is no standard that controls what is a transient error or what is a permanent error. It's more like common sense, and it's more or less device dependent. And this is probably because how we have implemented this in NSO. Let's go further and discover how the commit queue and its parameters affect the way we may or may not do error recovery. First, let's look at the atomic. When you have atomic false, you will always end up with at least one device out of sync when there is a failure. When you have atomic true, you will either end up in one of two states. If you have atomic true and you have error option continue on error, then you will end up with all devices out of sync. And if you use rollback on error, all devices will be in sync because of the rollback error option. When you end up with a device out of sync, that means you have the device configuration stored in CDB, but only parts of it have been pushed to devices. There is something that is inconsistent with at least one device. And the other is everything is rolled back. No device configuration is stored in CDB and all devices are in sync. We often recommend to use the commit queue atomic false option, because when you use atomic true, and push configuration to multiple devices and there are transient errors, there may be a rollback transaction on those devices that have received and acknowledged its configuration, causing a lot of unnecessary device interaction. With use of nano services, there is an option that enables the use of the best things from both worlds. The option is called Converge on Redeploy. It makes it possible to use atomic true with rollback on error, but to get a similar behavior as when using atomic false. It will cause the service to create a separate transaction for each device. So when there is a failure, the failed device will be rolled back, making error recover easier. Now I've talked mostly about the behavior of NSO. The interesting question is how do we actually solve when there is an error situation? I would say there are two strategies how to fix errors. One is going forward. The goal of going forward is eventually you want the configuration to reach the devices. You want the services deployed in your network. And of course, if forward is one way, then backwards is the other. And with backwards, the goal is to actually roll back everything that has been pushed. And this is including the service intent itself. One forward use case is to handle devices that are not responding because of power outage. In such a use case, you will probably set the commit cert items to a high value or even unlimited. This means NSO will continue until it succeeds to push configuration or if there is a permanent error. And to repeat what I mentioned before, is that it is not recommended to use with atomic true because of the rollback transactions it might do. And when there is an error, how do you handle that? When you use the forward strategy, devices will be out of sync because the config is stored in CDB and you need to fix that. The problem with devices out of sync is that they will block any other transaction, and that is bad. So the way to solve that is you either do a sync from, or you might do a sync to. My personal favorite is to actually use sync from, because the most common cause of devices out of sync is out-of-band changes, and quite often you want to merge them into the config used by NSO. And when you have done the sync from or sync to, then you can do redeploy to push the service generated configuration to the device. And then if you choose a backward strategy, still you have the device, if you have a device that is out of sync, it's the same commands here, sync from or sync to. Then you do service delete to actually remove all the service intent and other configuration. And as a result of this presentation, I hope I will give you some homework. I want you to go home and think, what is your feeling? What is hard when it comes to error recovery? Are there any missing features in NSO that would make error recovery a piece of cake? Make a wish and we will think. And of course, let us know. Thanks for today.